are going to Today we are going to see one of the complicated topics in Java. Uh, in fact, I'll try to finish this today. If not, if I cannot finish this entire thing today, we'll finish it on Thursday. So it's not so important for us to learn threads, but in some interviews, because most of the times in real world we don't really write any thread programs unless we are developing some new frameworks or new applications that have never been there. Okay, most of the times whatever applications that we build and all, there will be frameworks like Spring MVC, or if we are developing some desktop application, there is JavaFX and all. They will take care of the threads and all. But sometimes if you are creating any such frameworks, or you are at some advanced level, you may have to create some concurrent applications, so for which you may want to use threads. And also, if you are trying to go for an interview as a Java developer, they may ask you some questions on threads also. So even though it's not something that you use on your day to day, it is something that you better know. So what is Java concurrency API? Okay, in this session we'll be learning about what are threads, what is concurrency, how we can create threads, and what are executors, what are the various issues that we see, and how do we synchronize. Okay. So, so let's just quickly go through what is a concurrency. So, imagine you have a coffee machine in your office, okay, and the coffee machine, you will have to wait until other person finishes their job, okay. So only once you it cannot give multiple people coffee at the same time, right? So once a person finishes its job, and then another person will get chance to ask for coffee. Our computer is also like that only, okay. So only one thing can actually be executed at a time. We cannot execute multiple things, okay, at a time. But in reality, or in your practice, or in your usage of your computer, you may be seeing that multiple things are running simultaneously. You're downloading a file, and you're actually listening to a YouTube video, and then you are actually building your application, whatever that you are building. Okay. So on our day-to-day usage of a computer, we may be actually seeing that um, multiple things are happening simultaneously. Okay, and let's take another example. Okay, you may be having an application where you're downloading some hundreds of files. Okay, and then you click download, and the download keeps happening, and then you can it gives they give you almost all the downloading applications will give you an option to cancel the download in the middle. Okay, so now, what it does, it keeps on listening whether you're clicking on a button or not, and also it keeps on downloading the file, whatever is there in the background. Whatever is keeps on downloading the file, whatever you have requested earlier. Okay. So this is something called as concurrency. Okay. If we have to do it like this, okay, how do we do? We write a while loop, and while loop will be downloading a certain file, and every time it tries, after every second or so, it has to check if the user has clicked on the button or not, which is quite inefficient. Okay, so writing that kind of program is a little more complicated. So the Java concurrency API actually helps us write these kinds of programs pretty easily. Okay, let's see. And and what exactly is a thread? Okay, so thread is any set of instructions. Okay, for example, take this. Okay, downloading these files is in a while loop. Okay, that is a set of uh, lines of that is a few lines of code, and that we can call it as a thread. Okay, that process can be executed as a thread, and then listening whether the user has clicked the cancel button or not is another thread. Okay, so these two are two different things that has to happen simultaneously. Okay, so the Java's concurrency API will actually help us create these threads and run them simultaneously without having to do that ourselves. Okay, so now let's see what is a single threaded application. Okay, imagine you have a say for example this particular piece of code which you can see uh, around 10 lines of code, and that code don't have to worry too much about what exactly it is downloading, how exactly it is downloading, etc. But it is downloading some file, and once it has downloaded some file, it is asking the user to actually enter a name, and then once he entered a name, he say it prints file is downloaded by a certain user. Okay. So what happens when it is downloading? It stays in the while loop, and once the downloading is finished, it asks the user to give that name, and then it prints. Okay. But do you see the process of taking the asking the user to enter his name need not be done only after the file is downloaded. It can be done while the file is getting downloaded, or it can be done while file download hasn't been started. But because the user entering the data is kind of slow, we generally enter very slow in terms of computer. So what we can do is we can make sure that that can be executed simultaneously when the file download is happening, so that there is no delay once the file is downloaded. Okay. So uh, and imagine if take our browsers per se. Okay, when we ask for any download, it asks you to give a file name. Okay, but what really happens is while you are actually setting up a path where you have to download it, and when you are actually giving a file name and all, the download process is still happening. Okay, so so that it actually saves some time in terms of not waiting until the user is finished giving its name, so that you feel okay that application is working fast. Okay, that's how all the Chrome browser and all work, or even Firefox, the latest browsers. That's how they are working. Okay, they keep on downloading even when you have been when you are giving the name, what name to be given, or where it has to be saved, etc. Okay, so imagine a multi-threaded application. Okay, where what you do, you typically split the code into two parts, or you can even call it two different threads. What happens is execution begins simultaneously in two parts. Okay, so while the download is happening, the file that user reading the file, sorry, taking the username and all, will be already read by the computer, and by the time it finishes, and then it immediately finishes the file download completed. Okay, so this is how a multi-threaded application work. Okay, so when you see when you see the you by the time the file download is done, user input and all, and everything is done, so user will feel that application has worked fast. Okay, so at least the total process will be completed in less time. But as is telling, both are getting executed simultaneously. In real terms, that's not actually what really is happening. Okay, first you have to understand what a process is. Process is an executable that we generate, or a program that we wrote. Okay, so when we are executing it, it's a process. Whenever we right click and say task manager, to open task manager, you see every application will have a process in your computer, right? Okay, I'm not sure if you have ever used Task Manager or not. Either Kishore or Srinivas, have you ever used Task Manager?
Yes, Buddha. I mean,
Yeah.
I used it.
So we use Task Manager. There it displays all the processes that are running in our computer. Okay, and each process can have one or more threads running in them. Okay, so what is a thread? Thread is individual pieces of code that can run independently of each other, like what we have seen earlier. So what a thread is a small piece of code that is a part of a bigger process. Okay, there will be at least one thread in the process. So even though you have not been writing any creating any threads earlier, you have been writing at least one thread. Okay, the main method is run as a single thread. Okay, that is called as main thread. So what really happens inside a process is, for some time thread 1 will be executed, and then thread 1 will be sleeping, and then thread 2 will be executed, and then thread 1 will be picking up the execution when the thread 2 is sleeping. So this way the each thread will be switching back and forth, and this process happens so fast that users like us feel that it is happening simultaneously. Okay, so even in our computer that's what happens. So multiple there is only one processor. It can only do calculation for one calculations in small pieces or even a single entities. Okay, but how are you able to download a file while you are listening to a YouTube video? How exactly are you able to do that? What's happening is the processor is being allotted between the processes. Okay, there, and so downloading is a separate process, and you watching a YouTube is another process. So the what happens is the actual the processor usage or your computer hardware usage will be switching between one application to another application, and the switching happens so fast that we feel like they are happening simultaneously. Okay, so it's all about user experience, not the real thing. Okay, if you let your computer do one single thing and without using any other applications, that will be that a single thing will be completed very fast. Okay, if you are using multiple things on your computer, what happens is you have to keep switch back and forth between each of the computer will be switching back and forth between processes. So you are able to use the computer for multiple things. The ultimately the process that takes long will take longer. Okay, so the same way, even in single process, even in multiple threads if you create, they will be switched back and forth. Okay, so the switching happens so fast that you don't notice that only one thing is getting executed simultaneously. Okay, but because as I said, just because there are multiple threads, it doesn't mean it doesn't always gives rise to the efficient programs. Okay, so so there are only few cases where the using threads is beneficial. Okay, say for example, there are multiple activities in your program, and their order of execution doesn't matter, and some activities uh, have some idle time. Like say for example, they are asking user to enter a name. Okay, a user entering a name, however fast he may be typing, in terms of computer he is entering very slow. Okay, so there is idle time between that keystrokes. Okay, so what happens is when there are such multiple things, multiple activities that has to happen, and some activities take less time than the other activities, and uh, have more idle time, then in that cases you can put that whatever thing that is sleeping in a separate thread, and make sure that you create a multi-thread application. Okay, so that way you can actually get benefit out of it. Okay, so when there are activities that take some time to finish, when you are downloading some file, imagine your program, you have to download a file, and when you have downloaded a file, you have to extract it and copy it into some folder. Okay, imagine you have to download 10 files like that. Okay, so what happens is you can actually write the downloading in a separate thread and extraction in separate thread, because download process is kind of slow. What happens is that same process, once a file is downloaded, the compression sorry the extraction thread can keep on extracting the file, and it can copy into the other place. Okay, this way you can actually save some time. Okay, you don't have to wait until all the files are downloaded. The extraction process can begin much earlier, at least when one file is available for its extraction. So even when the in even only in those cases when one activity leaves more idle time, then the threads are actually going to give you more efficient running of your application. And imagine our web servers or even our user interfaces, all our MS Word and everything is a multi-thread application. And have you ever observed that sometimes application will freeze without having to without responding to you? That means it is in a non listening thread. Okay, so what's happening is it got stuck in some other thread, like went into while infinite loop or something, and it's not sleeping anymore. Okay, and the control is not coming to the thread that is actually listening to our mouse clicks or keyboard strokes. That is when the application hangs. Okay. So when that goes into such infinite loops, there is no other thing except to end the program forcibly. Okay, so that's what we do, end process. Okay, so now to create threads, there are two ways. One is we can extend a thread class, and another one is we can implement a runnable class. Okay. So when we are extending a thread class, we have to override the run method, and when implementing run method, we have to implement the run method. Okay, so the difference is when you have created a runnable, when you implement a runnable interface, the runnable interface doesn't have any default definition for the run method, whereas the thread class will have a default definition. Okay, and but we can directly call a start method to actually start the thread, and whereas runnable method, you have to create a new thread object and pass that runnable object, and then you can start by regular thread dot start for the new thread object that you've created. Okay, so so extending thread looks like this. Okay, when we create a new class, we simply say extend thread and override, and run method we are going to override, and whatever we want to run independent of other execution, we'll be writing in that particular method. Okay, so to actually start the thread, what we do, we actually say, we actually create a new object of the thread and then say that thread object dot start method, and we proceed writing whatever code that we want to write in our main method. Okay, and extended thread also, so when we say start, that extended thread will be starting executed, execution of that thread will be the whatever we wrote in the run method will start getting executed, while at the same time the process in main also gets executed. Okay, so both of them run parallelly. And now if you see the output that has printed thread demo.main and external thread values are getting printed because the main doesn't have any longer running process, so it simply stops there. Okay, and external thread will be getting executed until it finishes its execution. Okay, and implementing runnable looks almost similar. We just say implements runnable, whereas in the thread demo, we have to create a new object called t and pass that implement runnable method and say t dot start. That way, we'll be starting. So there is no difference when it comes to implementing runnable. But only when you are actually start when you want to start the thread, then you do this slightly differently. Okay, so it's slightly more lengthier, but sometimes we may have to create our thread class. We may have to extend our thread class from some of our some other application, the class that we have built. Okay, so in that case, do if you have already said extends thread, you cannot actually extend from another class, right? You cannot have multiple inheritance, you cannot inherit from multiple classes, so you cannot do if you extend from thread already. So that's why we have an interface. Okay, because we can implement from multiple interfaces, sometimes we will have to use this runnable interface also. Okay, so let me show you whatever I have been speaking, so that you will understand more. I hope you have been using NetBeans instead of Eclipse, so that you get familiarized with it. So in the break, have you guys written any programs, not just the assignments? Any other programs have you touched?
No, Buddha.
Okay. Try to see. There are many websites like CodingBat, etc., where they give you some sample problems. Okay, you can actually try to solve those yourself, and also try to use the NetBeans so that you get familiarized with this NetBeans. Okay, external class, finish. I'm sorry, I created. Now, as I said, uh, let's whatever code that we want to run simultaneously, let's put it in this. And one way to do it is extending a thread class. And when we extend a thread code, what we have to do, we have to override the. Okay, now we have created one thread. Now let us call this thread, and so that we'll get more understanding. Now, how did I say we can call the thread? We can simply call the thread by creating a new object of that. Now, how can we call invoke that thread? T dot start. And now let's do some other thing here. Int I equals to 0. Sorry, let's start at 100. I equals to 100. I is less than, sorry, I is greater than 0. I minus minus, and main, let's just print I. Now, so what happens here, this main also takes some time. Okay, it has to print 100 numbers, and because we have started the thread already, by the time we come, what happens is once this line is executed, when the thread is getting executed, this won't be stopped. Okay, the program will not stop here. So far what we have seen, whenever we call a method, until the method gets executed, that method will be so the program execution will stop there, right? This method will stop there, but here, because it's a thread, this won't stop like that. So now let's run this thread runner. Now let's see what's happening here. Now once we as I said, once we click the start method, or once we execute the start method, that won't stop there. It will be coming executing the next line. So our main has still getting executed. So now if you see, main has printed 100, and then it is printed 99, and it is keep on printing until 94, and then suddenly what happened is we have class extending that. Okay, and then once it has printed one number, and again the control came back to the main, and then once the class extension thread got the control, and it printed around 8 numbers, and then main got the control, and then it printed around 15 numbers, and then class extension thread main. So this way, what happened, if you see, what exactly we see over here is both are getting executed simultaneously. Okay, so in reality they are getting executed only one after another, but the process is allotting some time for that thread, and then allotting some time for the main thread. That way we don't actually do only one thing at a time. Okay, so now if you see, once the main thread has finished its execution, because it has already reached 0, the main thread has done, and then the rest of the time is completely given for our class extending thread. Okay, so this is how we can write threads that can execute programs simultaneously. Okay? Now the other way to create a thread is to implement a runnable interface. Runnable. Okay, because we are telling, and we have to make sure that we implement the methods and abstract, and the run method has to be there. Now let us have the same thing. Okay, thread runner, let's copy the same thing. So now what we are doing is we are trying to print the characters, okay, ASCII characters from 32 to 128. Okay, so just to see the difference. Now, as we have started this thread, we can also start the other thread also here itself. Okay. So, but as I said, what we have to do is interface implementing thread. We have to create an object of it. But if you see runnable dot, there is no start method. We cannot start the method. Okay, so there is no start method at all. So what we have to do is we have to create a thread object like t1 and pass whatever runnable we created earlier and start this method. Okay, now what happens, the class, this thread will be started, and then another thread will be created, and that thread will also be started, and then the for loop will be executed. In fact, while these are executed, not says when these are executed, we should not say when these are executed, we should say when these are getting executed, this also gets executed. Okay, now let's run the program and see what happens. Now, class extending thread has created around 7 objects, sorry, printed around till 7, and then interface implementing thread has printed a space, and then interface implementing thread has printed an exclamation, and then main thread has got control, and then interface implementing thread printed a double quotes, and then class, and then if you see, the interface implementing thread is also printing the characters. As we are converting the ASCII numbers to these characters, we are seeing all these alphabets and all. Okay, so the numbers and everything are getting printed by interface. So now if you see, the actually the time is getting shared between all these threads one after another. So once the thread is finished, it will no longer gets the control, and the other two will be fighting for the time. Okay, and this is when all three threads have been executed simultaneously. Okay, so this is how we can actually create multiple threads and write some process, so that when some threads are sleeping or doing some other activity that doesn't take so much of processor time, we can actually make use of that time by writing another thing. Okay, making sure our program does another thing. So as the slide says, we cannot start a thread that has already been started. Okay, we will be getting an illegal state exception. If we want to run the same thread in simultaneously, like say for example, you want to download multiple files simultaneously, or at least you want to show to the user that you are downloading multiple files simultaneously. What you have to do is you have to create a new different thread objects and then start them separately. Okay, so if we come back to this, we cannot say this. We cannot say that t dot start or t1 dot start again. Okay, if we do this, what we will be doing is we'll be getting a illegal state exception. Now, if you see, we got an exception in main thread, and that exception is at interface implementer. So now because multiple things are getting simultaneously, it says we are unable to start this particular thing. Okay, and we are not seeing that exception here. But let's see. Let's remove the other things so that will be more clear. Now I've already started this thread. I'm trying to start again. Now, if you see, the printing is even the printing is also separate thread, so which is getting split between the executing that already started thread and this new thread. Okay, now we got this illegal thread state exception. Okay, to make things more clear, let's simply comment out this. Okay, so it's just a black thread. Now let's run this. Now it will be more clear. We got an illegal state exception, which says that the thread is already in starting running stage. Okay, so we cannot start that thread again. So if we want to do this, what we have to do? We have to create another object and then start that new thing. Okay. Now when we run this, it's the same. It's the same code. Okay, it's the same thread, and but that gets executed without any error. So let's uncomment these two again and run the program. Now, if you see, we don't see the differentiation between this class section thread and class because that's the same thread, right? So now, how do we differentiate between these two? We can differentiate between these things by not printing this classic executing thread. Uh, Let me just show you. Thread dot current thread dot get ID. Okay, so every thread will have an ID, and now along with the class section we are also printing the ID of that thread object. Okay, now if we run the program, now we see the difference. Now first object whatever we created that got an ID of 10, and the second thread object have got an ID of 11. So now 10 is printed 0, and then 11 printed 0, and then 10 printed 1, 11 printed 1, and then 10 printed two numbers, 11 printed one number. So now do you see anything? There is no guarantee as to how much time each thread will be getting. Okay, so one thread may get more time and the other thread may get less time and all. Okay, so now if you see 11 has finished its execution, even though 11 did not start, 11 has finished before the 10. That's because 11 has somehow got the more time out of the entire execution process. Okay, so this is how we can run the same thread simultaneously. So now, because we are telling multiple threads can run, but our system may not be able to do all those things at once. Okay, let's say say the download managers, you can set a limit as to okay how many files can be downloaded simultaneously. You may say three, and then what it does, it will be waiting for other files to start. Other file the It will be starting three downloads simultaneously, and it will be waiting until one of them completes to pick up another download. Thread pools are also something like that. Thread pools will have a thread pool. It's like a waiting bucket. Okay, whatever process threads that are there, thread pool is something that manages in terms of okay how many threads can run at a time. Okay, depending upon the setting we set, those many threads are running. Because of our computer will have a limited set of processing capabilities, we should not be creating hundreds of threads just because we think it's going to be efficient. Okay, so what we do, we can make use of thread pool concept in Java so that the process will be simpler. So what happens is until one of the thread has finished its execution, thread pool will be maintaining, and then the thread pool will be taking threads into the running pool. And once all the running threads are completed, the entire process will be finished. Okay, so this way thread pool will be doing this kind of managing. Okay, how many threads are running now, and how many threads can execute, how many threads are waiting, and when one thread is sleeping, bring another thread to the running pool. This way thread pool actually manages these things very efficiently. If we have to create a thread pool that can do this kind of management, that is very complicated. Okay, creating thread pools is very complicated topic, but our Java concurrency API has provided a very simple mechanism to do that. So they created a class called executors, using which we can actually create a thread pools, different kinds of thread pools pretty easily. Okay, if you see the new fixed thread pool, uh, say for example we give a number to it and it creates a thread pool object, and to the thread pool object we can add multiple threads. Okay, and whatever number we give, it will be running that many threads simultaneously while keeping the others in waiting. So what happens is once the one of the thread is done, it will be bringing another thread that is waiting into the running pool. And then new single thread executor, what it does, it takes all but only executes one thread at a time. Okay, it doesn't actually switch between the threads. Only it waits until one of them is complete and then brings in another one. Okay, the same way, cache thread pool will keep some threads in cache and all. It's not that important at this point of time. We will see this later if the time permits. Okay, so typically the code looks something like this. We can create a thread object, and we can put say that executors dot a new thread, fixed thread pool, and we can give say for example 3, and then we can keep on submitting the same runnable object, and it will be creating the thread objects and it will be executing them. How it executes simultaneously, maximum of 3 at a time. Okay, and then once we say shut down, it will be waiting until the all other threads have completed its execution. Okay, so 6 threads have been added, and then when we say shutdown, all it will be waiting there until all the things are completed. Okay, so let's see a small demo of this executors. So executor thread is nothing but a thread pool. To create a new object, we call the static methods on the executor class. Executors class, not executor. Dot, let's say new fixed thread pool. Okay, and let's give 3, and then that will be the thread pool will be created. So now let's create interface implementing thread. Now all we have to do is thread pool dot submit. We can give the runnable. Okay, and we can give the runnable any number of times, or we can create other threads. Okay, we don't really have to give only one type of thread. Extending thread. Okay, this way we can actually give any number of times. Pool dot submit dot runnable. So now let's just give it 2 so that it will be able to observe it, and then thread pool dot shutdown. Now, so what really happens is, so 5 threads are submitted to this. So because we mentioned 2 here, only 2 threads will be executing simultaneously. Now let's execute the program and see what happens. Now interface implementing thread is getting executed. Okay, let's put that ID thing in our interface implementing thread also. So the class extending thread got an ID of 12, and then interface implement thread got an ID of 11, and both are executed. So now we see 12, 11, 12, 11, and we only see only those 2 thread numbers, okay, thread IDs. And when one of them is completed, only we those 2 will be executed. Let's go to the point where one of them is done. Now, if you see, the class extending thread has finished its execution. It has reached 100, so it has ended. And then interface implementing thread 11, and then it got another interface implementing thread. Okay, because we have added the same thread object again, so runnable object again, it created another thread of that. But because we got 12, because the 12 is already completed. Okay, we as we have finished executing the 12 thread with ID 12, we the new thread has got this 12. So now you see 11 and 12. Earlier you saw 10 and 11 and 12 only, but they are two different. And now we see, we will be seeing the same kind of things. Okay, because one thread finishes the 12 or 11 will be completed, the other thread will be picking up that 11 or 12. So we see the same things, but you see the same thing is getting happening simultaneously. Now instead of saying new fixed thread pool, if you say new single thread pool, new single thread executor, now what happens is, if you run the same program, now you see interface implement thread 11 is getting executed and no other thread is there. And when it has finished its execution by printing all the numbers that all the characters it has to print, and then we got the control for another thread. Okay, so another thread got created, and only the class action thread is getting executed, and then when it is done, the interface implementing thread. So what happens is, this actually manages in terms of how many threads can run at a time, very easily. Okay, we don't really have to wait until all the sorry do that same logic of creating all the implementers and everything. Okay, so this is how we can use the executors to actually do some things. Okay, but when we are running multiple things simultaneously, we get to we get into a lot of problems actually. Okay, so we do see, one of that problem is a race condition. Okay, so the race condition is something that happens when, say, for example, multiple threads are getting executed. So what happens is, let's say the same operation has been picked up by the multiple threads. Okay, imagine you go to a bank, okay, where uh, you you may be thinking, you have dropped in check in an ATM. Okay, let's say that that check has been scanned and has been given to the and will be given to a specific teller of a bank, and he will be verifying the scanned check and verifying the signature whether it is correct or not. and if it is correct, he will be adding that much or deducting that much amount from the bank. Okay, or adding that much amount to the bank depending upon what you did. Okay, let's take a case of adding money. Now imagine you have dropped two checks, okay, into the bank, and the two checks, the scanned copies of the two checks have been given to the to two different tellers, okay, unknowingly, or knowingly or unknowingly, it doesn't matter, it has been given to the two different tellers. And now so one check is of amount $1,000, another check is of amount $500. You already have $300 in your bank. Now because you have added two different checks, the total amount has to be 1,800, because 3 plus 8 plus 5, sorry, 8 plus 10 is actually sorry 3 plus 5 plus 10 is actually 18. So the ultimate final amount should be 1,500. Okay, now imagine these two tellers have got this say the check simultaneously. Now what they will be doing is, imagine that they got your account simultaneously onto their screens. They see that you already have 300. So because now $1,000 check, one teller is seeing, okay, now because you have got $1,000 check added to your account, now you should be getting 1,300. So she will be entering 1,300 into your account and then pressing enter. Imagine the other teller has already got the $300 balance onto their screen, okay, before the first teller has saved it. Now that teller has got $500 check. Now what she thinks, she may be thinking that, okay, because you got 300 already and you got 500 more by this check, now we should be getting $800. So now she will be entering 800 and pressing enter. So now what happens, ultimately instead of your balance becoming 1,800, your balance becomes 800. Why? The changes saved by the changes saved by the first teller has not been received by the changes that are getting received by the second teller. Okay, so this happens, this is called as race condition. Why is this called race condition? Because whoever enters their value first, that value will be lost. Imagine second teller has entered 800 first before the first teller has entered 1300. What happens? That 500 will be lost. So this is called as a race condition. When multiple processes are happening doing same thing simultaneously, there are chances that you may be losing some of the states unless you are careful. Okay, so how can you be careful? We will see. And another thing is called as deadlock. So as I said, we have a situation called as race condition. To solve that race condition, we use some mechanism called as locking. Okay, so what we do is, when one teller opens that particular user, okay, or user's account, what happens is that will be locked. Okay, so that account will be locked for any other teller to open, okay, or at least update. So what happens is, because you have locked it, other tellers cannot open your account. So we'll wait until they can open yours, and then once you have released it, then they will open your account and they will be doing the job. So because of this, what happens is, because of this locking process, the second teller will only be able to open it once you are done with your edit. Okay, but this actually brings another problem called as deadlock. Imagine you are opening something that teller 1 needs, and the teller 2 needs something that is opened by teller 1. So open in the sense locked. So what happens is, each one is waiting for other to release a certain lock on specific entity. So this situation is called as deadlock, and they will never be able to finish it. So we will see with more examples in subsequent slides. And then there is another problem called as starvation. Okay, starvation is when only one thread gets all the attention and other the threads won't get attention at all. Okay, those threads won't get any processor time. This process is called as starvation. Okay, so imagine the race condition, whatever I have explained before. Imagine you have written a program that actually increments the thread that actually increments a particular value by 1. So now imagine there is one thread that read the value into its own memory from the memory where that value variable is stored, and it increments it, and then it stores the value into the memory, so there is no problem. Imagine there is another thread which has come into the place that read the value, incremented it, and stored it. There is no value. So the 25 has become 27 because two threads have been executed. Two incrementing threads have been executed. Imagine both are executing simultaneously. You know what happens? Both have read the value 27 to them, and then both have incremented internally. So now what happens when one is storing 28, the other also stores 28 only because thread 2 doesn't know any change done by thread 1. So this is exactly the same case of what I've explained in terms of bank tellers and your check. So how can we actually solve this problem of synchronization? Okay, we can solve the problem by using synchronized blocks, or we can even use lock classes. Okay, synchronized blocks are a mechanism that has been introduced by Java to actually lock on a specific object or a specific entity. Okay, so lock classes are also something like that only. We will see their example in subsequent slides. So what you do, so first take a specific thread class where you have called where you are calling an incrementer. That incrementer actually runs for a long time. How it does is there is a class called race condition demo, and whose value will be read by v, read into v, and it will be incremented, and then it will be sleeping for a second, and then it will be copying that value into that race condition demo dot value. So now if we run the same program as is, uh, it will be facing an issue. So what we do is we use a keyword called as synchronized. So the synchronized keyword, what it will do is it will make sure that only one thread can access this particular method at a time. So until the thread 1 finishes its execution, the thread 2 will not be able to enter. Okay, so because of which, because of this synchronized keyword, the execution will be happening one after another, because this incrementer class is something that can cause race condition. Why it can cause race condition? It can cause race condition because it is reading a value and then incrementing and then sleeping 1 second before it can actually write the value back to the race condition demo dot value. Okay, while it is sleeping, another thread can enter and can read this value, and then it can be actually reading the same value, and then it can actually save the value, and then a second thread can save the value because it has entered it has entered late. So now what happens, the update will be lost. So by using the synchronized keyword, we will be locking the method to be available only for a single thread at a time. Okay, so that is how the incrementer method will become synchronized. Okay, so now how does locking mechanism work? Let's see. The thread one, first what it does, it will be acquiring lock because the incrementer is static memory which will be accessible by both the threads simultaneously. What we do is we first acquire lock. The thread one will be acquiring the lock, and then thread two will be trying to acquire the lock. It cannot because it is already locked by another thread. Now reading the value, and thread two will keep on trying to acquire the lock, but it will never be able to do that, and incrementing, storing, and then lock will be released by the thread 1, and then thread 2 will be able to acquire the lock on this incrementer thing. Okay, and then it will be reading value, incrementing the value, storing the value, and releasing the lock. Okay, so what happens is now we saw, even though multiple threads are simultaneously getting executed, because we are using this locking mechanism, we are actually getting saved from this race condition. Okay, so we can use synchronized keyword in various ways. We can use synchronized keyword on the synchronized on the static methods like this. So the entire method becomes synchronized, and then we can say, for example, you can synchronize on a specific class object like this. Any segment inside the method we can do, or we can even say synchronize on this current object, whatever is running. But here we have to be careful. If that method is in a single thread is in a thread, what happens is that thread may be access that thread each thread may be having a different this, so they won't be locked. Okay, so make sure that this incrementer method is not inside the thread object if you're synchronizing on this block on this keyword. Okay, so this way we will be able to have multiple methods that call the same incrementer method. And then alternatively, we can use lock classes that are like, say for example, there is a class called reentrant lock that actually where we can create a lock object, and the same lock object can be shared between multiple threads. And what we can do is we can say, for example, locker.lock, and then the next subsequent say lines of code will be locked for any other threads. Okay, so until the locker will be releasing its lock, then other threads won't be able to enter that piece of code. Okay, so this way we can actually use the synchronize keyword. So let's first actually uh, generate a race condition, and then let's try to solve it. So let's say there is a value holder class that will be storing that will be having a static variable, public static int v equals to 0. Okay, now let's create a long running thread, Java class. Now here let's call a method called as incrementer, and let's create a method. Let's make it static. So in this incrementer, what we will be doing is we'll be reading the value from value holder. Okay, and then we will be incrementing it, and then we will be storing it back in value holder dot v. Okay, but because there is no delay, because it happens so fast, we will not be able to make sure multiple threads will be entering. So before the second thread can execute this, we may be finishing this execution. So because to replicate that behavior, let's sleep for some time. So now this execution takes 1 second. So we can be pretty sure that the other thread will be coming into the picture. So now we'll be calling this incrementer thread. And now we'll be saving it. Okay, so now let's create a demo, and here we are creating an object of the long running thread. Let's create a long running a runnable. And then how do we start it? We have to create a thread object and pass the runnable, and let's create another thread object, pass the same runnable. Because it's a new thread object, this can be executed without so now let's start both of them. Now let's see what happens. Now let's run the program. So we entered and exited from both the threads. but we have not been checking whether the value is increment or not. Let's first print out what is the value in this value holder before executing both the threads and after executing both the threads. Now, first let's imagine there is no sleep at all. Okay, now let's run this program and see what happens. So the value before is 0, value after is also 0. Why? Because the main thread has executed so fast before the other threads have got chance to actually execute. So what shall we do is let's sleep for some time, say 1000 milliseconds, and now execute the same program. So while the thread main, sorry, this actually has to be. Now, while the main thread is sleeping, the other threads will finish their execution. So finally, we got the value as 2. Now, because the multiple threads have not been switched, because the process this process happened so fast, there is no chance for the synchronization or even the race condition. Okay. Now let us actually introduce a lag. So that means while this thread is sleeping, the other thread will also be picking up. So the value will be read, and then we'll see the actual race condition happening. Now let's execute the same program. Now what happened? The finally we only got one, even though multiple threads are getting executed, because each thread is overwriting the second thread is overwriting the changes done by the first thread. We are losing the changes, so this is why we are calling it as a race condition. Okay, so now to solve the race condition, what we do, we actually put a keyword called as synchronized. Okay, it is actually Z, not S. So now let's run the program and see what happens. Still we got one, and then we got exiting. So that means before the other thread finishes its execution, main thread has completed its execution. So let's put it as 2500 milliseconds. So that main thread will wait until the other two threads will be finishing their executions. So now when we run this, so both threads have exited, and now finally the value is 0. So how did it work? Because we have introduced a synchronized keyword here, we are actually locking that particular object. Okay, so imagine this is not a static object. Okay, now what happens is if we say synchronized and if we run this, we still got 2 over here. Okay, because it's the same runnable object, we are actually not getting any sorry locking condition. Okay, so this is how we can actually solve the lockings by using the synchronized keyword. Imagine we don't actually lock the entire block, we only want to block reading of this variable. Okay, reading of this variable and this internal thing. Then case what we have to do is we can use synchronized keyword, but we have to lock on something. Here earlier we locked on this method, so now we want to lock on something. So we can lock on this class object dot, we can say class. So what happens is this entire class will be locked for a single thread, or we can even lock on something that is common between the multiple things. We can lock on, say for example, okay, but because this is not an object, we are unable to do it. We can do it, change it by integer, and now we should be able to do it. Okay, here we have to give an object, not a primitive data type. Okay, so now what we are doing, we are locking on value holder dot v. Okay, whatever thing that gets uploaded, we are locking, so only one thread can access it at a time. Okay, so now even now we will not be seeing any race condition. Okay, so this is how we can actually solve the race condition by using the synchronized blocks. Okay, or even we can create a lock object. Say for example, reentrant lock. Okay, so this has to be static so that multiple threads can access it at a time. So now instead of synchronize, what we can do is we can say value holder dot lock dot lock, and then here once we are done with it, dot unlock. Okay, so now this also achieves the same thing. Okay, so we have locked it and then we are unlocking it once we are done with the updation process. Okay, so this is how we can actually solve this. Okay, imagine we keep this particular locking operation after reading it. Okay, now we lose the advantage of it because the previous thread has already read this particular portion. We actually lose that actually the synchronization at all. Now we should be seeing one only. Why? Because both threads are able to execute this line without any issues. So both threads have read 0. Okay, earlier when we kept lock here, only one thread is able to read this value. So what happened, when one thread has finished its execution, the value is 1, so second thread is reading this value as 1. But if we don't lock there, if we lock it later, what happens, both threads will be reading the value as 0 because they, and then one thread will be acquiring lock and finishing it, and the second thread will be then once the first thread is unlocked it, then second thread will be acquiring the lock and continuing. But because it has already got the value as 0, subsequently we will lose the advantage of the locking at all. So always be careful about what you are locking on, where you are locking, etc. Okay, and also I said we can use synchronized of this keyword. Okay, but if we use that this keyword, because these two thread objects are different, we won't be actually locking anything. Okay, so that is how we can use solve the race condition. Okay, um, but we can go to deadlock, but I think the time won't be sufficient for us to actually finish the other things. In that, I'll finish this rest of the thread session on Thursday. I actually want you guys to create a thread class, threads, and try to execute some of these so that you get an understanding of it. Okay. The deadlocks and some other thread problems we will be seeing on uh, Thursday. Okay. So time should be sufficient to for us to be able to finish it on Thursday. So do you guys have any questions on this? I think we already lost Kishore. Srinivas, you are there?
No, 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 I am there.
Yeah, okay, okay. So, do you guys have any questions on these threads?
No, Buddha.
Okay. Fine. Try to practice these threads. Just create some threads and execute those threads. You will get some more questions, etc. So we will take them up and finish rest of the thread session on the Thursday session. Okay.
So
Okay.
what about tomorrow, Buddha, then?
Uh, tomorrow. Oh, tomorrow is Wednesday, right? Yeah, there is session, so we'll finish it tomorrow only. Actually, Thursday there is no session, right? So we'll finish it tomorrow.
Okay.
Okay. Thanks a lot. I'll upload the video and